Hello, my little mathematicians. Today I'm going to help you get started on your homework of multiplying fractions by fractions. Okay, so you multiply across when you're multiplying fractions. So like 10 times 4 is 40 and 12 times 10 is 120. And then to create equivalent fractions, in case it's multiple choice, you can reduce it until you get the one they're looking for. Or if it wants down to simplest form, you keep going all the way to the bottom. In order to make sure that you have it in simplest form, in case it's a question that wants it in simplest form, cross-canceling is the easiest way to do it. So you look at the numbers that are diagonally across from each other. So look at 4 and 12. Can you think of a number that can go into both 4 and 12? Yeah, 4 can. What's 12 divided by 4? 3. And what's 4 divided by 4? 1. So now these are much smaller numbers to deal with. Can anything cross-cancel these? What can go into both 10 and 10? 10 can. And 10 divided by 10 is 1. And this 10 divided by 10 is 1. Now when you multiply across, you have 1 times 1, which is 1, and 3 times 1, which is 3. So that is, if you started with 10 times 4 is 40, and 12 times 10 is 120. So 40 over 120 is equivalent to 1/3. 1/3 is just that same fraction in simplest form. So cross-canceling makes it a lot easier to get to simplest form faster. But again, 40 over 120 is still equivalent to 1/3. Okay. Can you cross-cancel anything here? Yeah, what can go into 4 and 12? 4 can. And 12 divided by 4 is 3. And 4 divided by 4 is 1. And then when you look here, nothing can go into 1 and 13 other than 1. You get the same numbers. Okay, so now when you multiply across, 3 times 1 is 3. And 13 times 1 is 13. That can't reduce any further, so that's simplest form. Yes, 12 over 13 times 4, what is that? That is 52. So 12 over 52 is equivalent to 3 over 13, but I want us to at least practice getting it in simplest form if we can. All right, and right here, what can go into 5 and 10? 5 can. It's easier sometimes if you show what you're dividing by, because otherwise you might make simple mistakes. Okay, 5 divided by 5 is 1, and 10 divided by 5 is 2. Now what can go into both 6 and 12? Yes, 2 can. Can you think of something bigger? 3 can. Anything bigger? 6. And what's 6 divided by 6? 1. And what's 12 divided by 6? 2. Now when you multiply across, you have 1 times 1, which is 1, and 2 times 2, which is 4. Now if you just multiplied across and got 30 over 120, yeah, that's the same thing. Or what if you reduced it by 2 and you got 15 over 60? That's the same thing. Or if you reduce that by 2, nope, not by 2, because 2 can't go into 15, but by 3. 15 divided by 3 is 5, and 60 divided by 3 is 20. And then, oh, look at that. 5 can go into both of those. 5 divided by 5 is 1, and 20 divided by 5 is 4. So look at all that work to get to simplest form, rather if I had just started off by cross-canceling. Okay, now all of these are still good answers. 30 over 120, 50 over 60, 5 over 20. All of those are equivalent fractions, because in order to get them, here I just multiplied across. 6 times 5 is 30, 10 times 12 is 120. But then I reduced them by dividing both the numerator and the denominator by the same number. So that created an equivalent fraction here. I did the same thing. I reduced by dividing the denominator and numerator by the same number, okay, and so on until I got to the simplest form, okay? So any of these would work if it didn't specify simplest form, but if it does specify simplest form, then only 1/4 would be the answer. The others would be like probably half of a point. Okay, so at least practice trying to get it all the way down to the denominator to simplest form. And then if you check your answers and you didn't get it in simplest form, check to make sure that your fraction was at least equivalent one to the one showing. All right, you got this, my little mathematicians. Ready, set, go.